Perfect. Well, and I appreciate that. But really, this AMA is not so much about me. Really, it's really to talk to Atik, who's a SCYTHE's head of engineering, and kind of do a bit of Q&A from the SCYTHE engineering perspective and from an implant generation perspective. And so, if you have questions, either here in the Zoom or in the Discord, I'll keep an eye on that. But really, we just want to take a little bit of time to go through just kind of whatever anybody wants to know. And I've got some pre-canned questions as well. But yeah, that's what we want to do for the next half an hour or so in the run up to the happy hour. So Atik, if you could come off a mute there and give us all just a quick introduction about who you are and your background, and we'll kind of go from there.
Hey, yeah, so I'm Atik. I'm the head of engineering for SCYTHE. And prior to SCYTHE, I used to work for a government contractor working on implants. That's about it as a summary. Prior to that, I actually worked on the defensive side as well. And before that, I worked on web crawlers. So that's a very quick summary of what I've done.
So I guess to jump in, Atik, obviously, like yourself and the SCYTHE engineering team has been doing a lot over the past chunk of like the last, handful of years or so, but, specifically in the past 6 months, there's been new product releases, new product portfolio stuff, obviously the launch of the marketplace today and the SDKs and all these things. Like it's pretty incredible. And if people have questions about any of that stuff, we can of course talk about them. But one question I have for you right now is, developing of C2s and implants is a huge deal right now. So for example, there's the C2 matrix, which myself, George, Bryce, we helped get started, and there's like 50 some odd things in there. But given how big that is right now from an open source and commercial standpoint, do you, as someone who develops these things, C2s and implants, can you talk about from your perspective, what like the state actor or the government actor perspective of C2s and implants, and maybe, I'll leave it to the audience, but maybe can find some differences between maybe the way the open source community thinks about C2s and implants versus whatever your insights are. So does that make sense as a question, hopefully?
I think so. I'll try to answer it. There are some aspects I can't get into, if that makes sense.
Sure.
So yeah. So basically, when we consider state actors, you have to consider what you need to first consider is the actual threat actor. So different threat actors have different motivations. So in the case of state actors, their motivations are going to be very different from somebody with a motivation for near-term financial gains, for example. So in the case of state actor, what they're interested in is not to be discovered. Like from their perspective, being discovered is actually a huge red flag. So most of what happens, you're never going to know that they were there, what they were looking for, and when they left. Like they will do their utmost to prevent not only them being observed, but seeing anything that they've developed at rest even. So that's their purpose. Most of how they deploy, most of how they do things, a lot of it will I can say will be in memory. Like you're not going to see any artifacts on disk. They don't want to be, basically they just don't want to be inspected. So did that answer your question?
It does. And this is one of those things that you hear a lot about in the industry and in InfoSec about how, if we look at something like Metasploit or Kali, a lot of the built-in things that people use those tools for are very snatch and grab, like pen test, kick the door in, exfil as much crown jewels as you can and get out of there, which is all well and good, but it seems to be that kind of tooling is very short mindset, for lack of a better term. And I think there's a perspective, it's like, well, that's cool, but it doesn't really entail how state actors think, right? Especially, and you think when we hear about state actors whose operations and cyber operations span like decades, where there are cyber offense programs that are occurring that, you know, for all intents and purposes, the person who created it will probably be dead by the time it's discovered or shut down. And would you say that that's kind of that time span difference is something that is is notable? Like, is that one of the key differentiators between kind of snatch and grab pen testing tools and state actor implant C2s?
Yes. So basically, there's the whole aspect of target enumeration that's going to happen first, right? So they're going to spend a substantial amount of time trying to figure out what exactly they're trying to get into. Most of the other threat actors will not spend that much effort because they actually don't have that much resources or that much money or even time. So in the case of state actors, they have a lot of money, they have a lot of time. They don't care, like their budget is not infinite, but almost near infinite. For example, you know, they can spend millions of dollars just to turn one bit on or off if they want to. And most of the commercial world does not have that kind of resources to be like, hey, here's some money, here are a couple of devs, go spend as much time as you need, solve this problem for me. Yeah, so it's very different, right? What they're looking for is something that will last, you know, half a decade. Well, I wouldn't say they're looking for something that will last half a decade, but they don't. What they're looking for is something that won't be caught in half a decade. Yeah, I mean, I really don't want to go too much into
no, that's okay.
Into that, unfortunately.
That makes perfect sense, and I that really has a lot of echoes of like standard, like again, pen tester red teaming thought, and where you're targeting endpoints versus like ICS infrastructure targeting, right? Where someone who's trying to knock over a database has pretty explicit goals, but someone who is trying to be inside of a power grid has a very different span of what recon is and what stealth is, and just like it's almost the entire mode of thinking is completely different in that perspective, and that's kind of interesting to think about, and then turning that on its head and saying like, well, how is a blue team at like a small regional bank who may actually be targeted by threat actors for whatever reason, you know, state actors, what possible recommendations can you provide them, given that they're kind of so outmatched from a resourcing and timing perspective?
Oh, I mean, the sad part is that there really isn't anything you can do if a state actor is gunning for you, if that makes sense. Mm-hmm. Short of you calling your own government and saying, hey, like, what's going on here? And then they'll start to look at it, right? But I mean, like, it's not a, yeah, the amount of resources they have versus the amount of resources you have, it's pointless. Like, you really don't have much of defense. And for example, I don't want to use examples, but for example, when I believe Eternal Blue was leaked, right? And you saw the consequence of that, not in the US, but outside the US. There really isn't much you can do being a small business against a state adversary.
Got it. No, that's good insight, and you know, one of those. It's unfortunately it seems very doom and gloom on the face of it, but in reality, it's, you know, it seems like a lot of fundamental defenses might be valuable. Like if you've got network monitoring in place and you're looking for weird beacons, like that's a big deal, right? There was that report that came out that someone who was coming to work every day for like 5 years was actually like turning a VPN on and outsourcing all the work they were doing every day, and nobody discovered it until they turned on network monitoring, and they're like, well, that's kind of a weird connection happening there. So I mean, it sounds like fundamentals are key even when you're going up against state actors, but still not a
Yeah.
lot can be done.
Yeah. So having said that, what I can tell you is, cloud vendors are probably going to be more secure than your own infrastructure. They have, they're actually spending budget to ensure that what they have is sufficiently secure, and it's probably going to be more secure than anything that you can do in your own small infrastructure team. So having said that, if you're a small business, the recommendation would be for you to use as much as you can to offload that to a cloud environment. Having said that, you still need to you have to ensure your policies are still correct, right? The only thing cloud vendors are going to do is they're going to ensure that their infrastructure is secure. They're not really going to, if you forget to put up a firewall, it's not something they're going to do for you, right? If, for example, if you leave your RDP port open, they're not going to say, hey, by the way, you left this RDP port open, and anybody from the outside the world can actually get to it, right? So that's still your responsibility. But hosting a lot of stuff on the cloud is actually, and I can't believe I'm saying this because I was actually really against cloud, I would say roughly 5 years ago, right? But seeing what they've done, or at least from a security perspective, I would say they're probably better than you hosting your own server environment.
All right. So we got a question in the Discord here about where did this type of framework spawn? Did it come from red blue team exercises and bug hunting and something we built upon and that sort of thing? So I'm assuming that the framework in question is kind of the way SCYTHE has been built out as a product. And from my perspective, this thing was born out of an engagement with, our sister company, Grim, where a large organization, Fortune 50 came and said, hey, we want to test and validate some defenses, and we're sick of using some off-the-shelf tooling. Can you all build us something? And then the proposals came back. Well, yeah, let's build you something, but can we keep the intellectual property for it? And and the rest is history. But that's very much kind of the business perspective on it. I would love to hear from your perspective, the way SCYTHE is modular, the ease of use of it, the way we build out payloads, and the way that these modules can be built out using SDK. I would love to hear from your technical perspective, what is the genesis of the way SCYTHE is built? And this is something that you've patented as well, correct? Your name's on that patent.
Yeah, I think actually the entire team's name is on the patent. So I wanted to ensure that everyone actually got credit for the work they did, and it was around the time, so the list of names on the patent are actually the folks who were actually working on the product at that time. So the initial request for something like this, or a remote access tool, came from one of the customers for Grim. Basically, so when we started, it was basically me and another individual, Ben Dagana, who actually currently works in Grim. And what we wanted to design was how actually a threat actor, a state-level threat actor, would do things. That was actually our purpose. Having some background as to how they do this kind of thing, if that makes sense. Mm-hmm. So again, not going into too much detail, but the specific goal was we wanted to, so basically, if you consider site stage 2, that can actually be loaded in memory. If you were to use some other stage 1 dropper to load this client into some other process, that's what site stage 2 is for. It's supposed to be something that you really can't detect because it's not going to leave a physical artifact. It's not going to leave an artifact on disk, and you can actually go further, how exactly you want it to be in memory, all of that stuff. That's actually left up to you, if that makes sense. But the intent of that was it's based off of how state level actor would do things. Basically, in terms of initial access, it really doesn't have anything that gives away what they're looking for. So the purpose of state actors is let's say somebody actually finds this binary on disk. You can't really docs and figure out who that state actor is. That's their most important goal. It should be ambiguous. So basically, like, for example, if you consider SCYTHE modules themselves, there really aren't any strings in the SCYTHE modules. And the purpose we did it this way versus how you would find other C2 or implants is that, in the case of state actors, they're really not going to want to leave any type of string artifact on disk or even in memory. So most of all our strings are actually on the server side, and basically they're tied to IDs on the client side. So when the client sends a response back to the server, it's just like, hey, this ID happened, and when you look at it in the UI, you see, oh, the UI maps that ID to that string, right? Does that answer your question? Or
it does. No, and I think what's interesting about that is it shows insight into the difference between the way we do things in SCYTHE versus the way just kind of like someone building an arbitrary command and control, like as a proof of concept would do it, right? Where we have specific things in that we do for obfuscation that was born out of the background that you have and the specific goals of saying, let's not just build a remote access tool, but let's build something that's slightly more state actor in nature. So I think that way of saying, well, we obfuscate to that degree, it really does answer the question about, kind of some of the differences. And we had a question real quick in here about, could you just basically describe the differences between stage 1 and stage 2 and what you're referring to when you talk about a payload, just for people watching?
Okay. Very good question. So from my perspective, a payload is, think of it as a little bit of shell code, and it's probably going to be the first exploitation. For example, let's say a browser or something that's connected to the internet. Like you found a way to put a little bit of code that gives you a little bit of more access to some memory that you can execute. So that, from my perspective, is a payload. Stage 1 is using this little bit of payload, you actually deploy some shared library. For example, on Windows, it's going to be DLL. And the sole purpose of the shared library is to do nothing but to communicate back to your C2. And basically, I would say, like in the case of state actors, they will tend to wait and see how long it takes for somebody to actually detect the stage 1, because if they lose stage 1, it's okay. Like they have so many stage 1s, right? And it really doesn't have much purpose other than connecting to C2 and deploying stage 2. Stage 2 tends to be more sophisticated, where this is going to be something that has more capabilities. And again, like all of these capabilities are going to be loaded into memory, and they're going to be loaded from the network. Like nothing's actually going to be baked into that stage 2. So it's like, yeah, so first there's a payload. The payload is, let's say, some little bit of exploit code. And then you load something else, which is more like a module, which can do only one thing. And that only one thing is going to some C2 and getting stage 2. And once you have stage 2, sorry, in the case of stage 1 also has another responsibility, and that responsibility is to identify if you're actually in the right environment or not. So for example, did you land in a VM? Did you actually land on the specific machine you wanted to land on, or did you land on some random person on the in the Midwest, right? And if you're in somebody's random machine, you just bail out. Like there's no reason for you to deploy your stage 2. If you've identified that, hey, this is the right environment, stage 1 responsibility also is, hey, is there some sensor running, and can I turn off the sensor? And once that's done, and you've ensured you have some guarantee that all of this is working, that's when you're going to start to deploy your stage 2. And then after stage 2, you can do additional things. And stage 2 could actually be many different variants. Like it doesn't have to be the variant that we're showing in SCYTHE. Like it could be a variant of where you have a client side, a user mode and a kernel mode part. Like you have two different parts doing 2 different features, because there's certain things you can do in kernel mode that you can't do in user mode, right? So it's like stage 2 tends to be a collection of components, or a collection of artifacts even, and some of them may even end up being on disk. So that's about it. So you will have a payload stage 1 and multiple stage 2s.
Perfect. Here's another good question from the Discord. So the idea is, because now there's a million C2s, and we've seen every C2 channel under the sun. For example, like, you know, you have the standard HTTP, HTTPS, DNS, what have you. And then there's all the ones you ratchet on top of those, like steganography. And there's all the ones that you can use other services, like, you know, Google Sheets for C2 and exfil and all these sorts of things. But the question is, you know, how often or to what degree do you think it's appropriate to use what are considered in this question like complex or like cute communication channels versus just sticking to the simplicity and basic ones? Like, do threat like state level actors ever spend their time making weird, crazy, complex beginning, nesting, all these other things? Or is it just at the end of the day, HTTPS with some end-to-end encryption and call it a day? Like, from your perspective, how valuable is like the cute communication C2s, and how real are those from a state actor perspective?
It's a very good question. So stage 1 is just going to be HTTPS in most cases. And the reason for that is widely available, not suspicious, right? Going to some, let's say it goes to some server with high reputation, as an example. Stage 2, the communication tends to be very sophisticated, and it's not something cute from my perspective. But basically, again, their goal is they don't want to be seen. So if you have HTTPS traffic, that's going to be seen, right? Like the amount of time and the amount of budget they're willing to spend to not be detected, I would say most of the commercial world is not interested in doing something like this. And like it will usually be one-off. Like one implant is not going to be the same as another implant in terms of communication or anything like that. So so the amount of effort they're going to go through that, even let's say you have some network device, let's say you have a Palo Alto or something that's actually scanning all of this, the amount of effort that they will go through to ensure that even those network sensors are not seeing this traffic, like they will do it, right? They have the budget to do something like that. So not only have they compromised your desktop machine, they've probably compromised all of your network sensors as well, just to get that information out in a way that nobody actually can see that information is going out.
I think, go ahead. Yeah.
Nothing cutesy. Yeah, nothing cutesy. Like it's not going to be steganography or Google Sheets or anything like that, because all those leave footprints. Like somebody can always see and look at it and see, oh, there's this traffic that went on. Like in the case of Google Sheets, Google can actually, like if they get a warrant, they can actually see what exactly happened. They keep track of everything, right? So it's not going to be anything cute, but it's going to be very, very sophisticated.
I think that's really great context. And this was something that we were having a conversation with some friendlies in the network monitoring space just like a week or two ago. And it was basically had to do with like a network analysis and beacon intervals. And we said, well, you know, would you notice a beacon that was every 10 seconds with, you know, 25% heart, like jitter randomization on either end of that? And they're like, oh yeah, of course. Well, would you notice beacons every 30 seconds with 50% jitter randomization on either end? Oh yeah, we would probably see that. What about 5 minutes with, you know, 75% randomization? It's getting a little trickier. And then when it came to the question of, well, would you notice a threat actor that beacons every 30 minutes? Some of the response we got was, well, how is that even valuable? No threat actor would ever accept that kind of latency in between commands. But, you know, based on the conversation we're having, that is like flatly not the case when it comes to state actors, right? You know, we're even though we are all in this rush, like Kali, Linux, Metasploit, go, reverse shell.
It's right. So state actor motivation is very different. They have, like, they're looking for something very specific, and time, budget, those things they have more of that they can afford than most of the commercial world or even the criminal world.
Yeah, and I think that paints an interesting picture for folks who are in the industry and saying and looking at things and saying, well, you know, for me doing a 24-hour red team engagement, I couldn't accept 30-minute beacons because I've got too many things to do. But that just shows the difference between that industry and when you're looking at state actor, offense, defense, just the perspective difference. So that, no, I think this has been incredibly helpful, Atik. Thank you for taking just the 30-minute time. I know you're busy, and you and the engineering team have been working hard on getting the marketplace out the door, but this has been incredibly helpful, and hopefully it's been helpful to everybody listening in. And I think we're just right on time here to start the happy hours. So.
Yes, that was awesome.
Yeah,
thank you, Atik. That was awesome. Always throwing some good knowledge out. And yeah, we are 2 minutes away from the end of the capture the flag. So if you don't mind, I would like to share my screen before we give you the links to the happy hour, which are going to be posted on LobbyCon. So you do have to be on the Discord. If you want to see the link for the happy hours, there's going to be multiple happy hours for you to attend. You can pick what subject you want to talk about, and of course you can jump from one to the other. But before that, there's 1 minute left, and I just want to show, like I said, this was a random idea based on a lot of CTFs I've played and other folks have played. I usually just like go on Slack and talk to friends and say, hey, have you ever done something like this? And the answer was no. I don't know there is a CTF where you actually have live payloads that you need to execute on your own system to then figure out what's actually happening. And of course we called it Know Your Payloads. And we use the C2 matrix, and it is 4:30, so the game is done. But I just want to show you some pretty cool stuff. So I think you can see my screen. This is the scoreboard. First of all, shout out to all, my gosh, how many of you? 54 of you got to level 3. That is amazing, amazing work. Congratulations to all of you. You can scroll down to that last question. There you get the link to fill out the form if you want to give us your address. We want to send you free stuff. We're going to send you stickers and a SCYTHE shirt for joining. And then if you want to get the grand prize, you will need to do a write-up of what level 3.exe does. Now, there's a ton of connections coming back, and there's actual things happening, right? So level 1, for anyone that's watching, was Posh C2. And this was my view. This is a DigitalOcean droplet that is the best I could get. And we had a total of 121 different beacons coming in. And obviously I can interact with these. I didn't, I just wanted to show you. Then level 2 was Empire. And we look at agents there. I've never seen this many agents, but over here we get 270 different agents. Now, why were there so many more Empire agents? Because Empire was level 2. And you actually had to run things like Sysmon and Wireshark and figure out the heartbeat and the jitter and all this awesome stuff. So it was great watching from this side. And of course, level 3 is a SCYTHE payload, which does some automation. Let me see if I'm logged in here. I'll show you real quick our view. Yeah, there are 73 payloads coming in. That CTF level 3 there, I'm not going to click on it because I don't want to share what's happening, but we see there's 19 active exploits right now. And this one, you're going to probably have to run through a couple of times because the automation is built in. It's going to do a number of things, and whoever does the best write-up will get a grand prize. We'll have the most creative write-up. So if you write something funny and we like it, you're going to win. The most technical one that's correct. And then a random draw. So as long as you submit something, either send it to me, follow the instructions there on the bottom, you will get the grand prize. And a total of 112 people played, which was awesome. And then if you want to learn how to create these payloads yourself, I'm going to do a 2-hour totally hands-on workshop For this one, you need to bring two systems, the same Windows 10 system you use here and the SANS Slingshot C2 Matrix Edition. That way, we're going to show you how to do it and, of course, walk through the entire game of how to enable Sysmon, how to follow each step, every network connection, the DNS, the process creates, etc. as we go through. So thank you to everyone that played. Any feedback on the CTF channel, we really appreciate it. Shout out to Dave Mayer, who was behind the scenes helping all of you out. And of course to SANS, C2 Matrix, SCYTHE, and CounterHack for allowing us all of this. And yeah, woohoo, top 50, that's awesome. So with that said, if you head over to LobbyCon, we are posting the 3 different happy hours that we're doing. We have a general on hacker rights one with Bryson, Liz, and Chloe, which we just heard of. We have a red and purple team with myself and Dave Mayer, talk about red team and purple team stuff, and C2 engineering and module creation, things like that. Although I saw the module dev, you guys were just talking about video games half the time, which if you saw Module Buster, you understand why. That is going to be over there with Atik, Adam, and Christine. So jump over there. We thank you all for joining us today. I think today was a wonderful day. We did a lot. We got a lot of great talks in. We had a DJ, which was new. We did that AMA, which was new. And it wasn't a big dumpster fire like some of the year has been for some of us. So happiness and giving back to the community, like Chloe said, is what we believe in. So really appreciate it. The first UniCon in the books, and head over to a happy hour. I'm not sure if Adam, Bryce, and Christine, you have anything you want to add here, but really thank you all for coming together and making this happen.
Yeah, a big thank you to everyone who's involved in everything from, getting this conference off the ground, and also, to the staff who got the marketplace launched and all the Module Buster stuff, and all the people who are trying out development, and everyone who's trying out the CTF, everyone who's been asking great questions. So thank you to everybody. Just as a community, we're making some really cool stuff together, and it's really appreciated. And I also love the ringing endorsement of UniCon 2020, quote, "It wasn't a dumpster fire." Like, we'll make
unlike the rest of 2020 for some, but we're changing it. We're gonna make this better.
This is just the beginning. This was the start of us kicking off the community, which now, like I said at the very beginning when George and I introduced our insurance conference, is a combination of how we can engage people as well as a technical exchange for threats and innovations in what can be done in offensive security. So stay tuned, join us on the happy hours,